Well, I wanted to talk about this mainly because our little visit to Infocom. I have to tell you, probably like a lot of you, I haven't been out in the world a whole lot in the last 2 years. I haven't been running around making any measurements or seeing how things actually are. And to end up a couple of 3 weeks ago in Las Vegas, which is a good sized city, and measuring all the interference and stuff there, I thought maybe we should talk about this. Because it's certainly something you have to be aware of to keep your wireless microphones on the air and going. So we'll start with always. This is our point of everything. This is what makes wireless microphones work. The fact that you can keep your signal at least 20 dB hotter than your noise floor. So, maybe just to explain a little bit to what that means. You're starting out with a signal of, I don't know what, plus 10, plus 15, maybe depending how powerful your transmitter is, 10, 20, 30, 50 milliwatts for unlicensed transmitters. And by the time it goes through air and through all the electronics, we'd like it not to drop down to, much lower than minus 65. So in this case, unfortunately, I don't have the side calibrated there, but what that means is that the signal, in this case, you can see it goes above the green lines, and that's good, but it has to maintain that above the noise floor, right? So our signal is going to be what it's going to be by the time we use all the electronics and stuff, and so what we're hoping to do is to get the signal back to your receiver at least at minus 65, right? It loses power going through the air, it loses power going through the cables, all that kind of stuff. And we have to have a nice strong signal. And we're somewhat limited because we can only use the transmitting power that the FCC will allow us to use. So all the manufacturers strictly adhere to that. It's easy to boost a signal, but it's not legal. So what we're really looking to do always is find a ways to lower the noise floor, and that would be all the garbage that's below the red line there. We'd like that to be even lower so that our 20 dB is even higher, and hopefully we're a whole lot more than that. So I hope by now everybody has seen this performance calculator. This is a free app on our website. You don't have to sign up. We don't need your email. We don't collect your mother's maiden name or anything. You just simply go to this and you go to all those drop-down boxes and just, put in the parts and pieces of your system. And when you press the calculate button, you get a green, red, or yellow light on the traffic signal there. If you get the green light, that means that your signal is at least minus 65 dB, which we're calling the noise floor minus 85, which is a pretty serious noise floor. So that gives you 20 dB. If your noise floor is lower, then it's even better, and that's all good for you. But so what the point of this whole talk today is to talk about things to help you lower that noise floor, right? There's two parts to making your radio work. So with our antennas and all the stuff we make at RF Venue and this chart, we can tell you that the signal gets there. What we can't tell you is what the there is like, how much interference you have. So even though the signal gets there strong, if you have too much interference on the other end, you won't have clear channels to tune to, or you'll have noise that takes you off the air. So that's the part that RF Venue can't control. We can control getting the quality radio signal to your receiver. And obviously, that's a very big part of this. Okay, so interference is kind of coming at you from, the world outside and from inside your radio. There's basically two parts to it. And they do sort of overlap. So don't think of these as actually two separate things. They're, you got to take care of both of them. So all the external things that are out in the world to get you, here's a list, and it's probably only 10% of the things, because basically down at the bottom, anything with a circuit board, right? Anything wireless, plus all these other things are all generating radio frequency energy. And that, it tends to be random. So that's piling up on that floor at the bottom. Go back to that first picture. That's piling up on the floor. So you need to be aware of these things. I mean, you certainly don't want to put your antenna right next to one of these, right next to your air conditioner, right next to your access point for your Wi-Fi, right next to video cameras that are broadcasting wirelessly back to something. You have to kind of be aware of these things. There's not much you can do usually about these things, but, just know that they're there. And then there's sort of things that are internal to your radio. And you may not know these terms. Co-channel interference just means that when you consider more than one wireless mic, it means that you're tuned too close to your other channel. And your frequency is not a single straight line, it's the tip of a pyramid. So some of the side of the pyramid is interfering into your other channel. There's adjacent channel interference. That's mostly intermodulation, and we'll talk about that in a minute. Obviously, there's out-of-band radios that can affect you. And then there's receiver blocking, which simply usually means you're getting a signal so strong from something that it's wiping out the front end of your radio. For example, can't put your handheld transmitter, 6 inches away from a diversity fin, right? The signal will be so strong that signal coming in will just overwhelm your radio. It'll like clip the front end, you should think of it. So these are all things that we have to think about. So there's basically 3 things I want to talk about. You just really need to incorporate these into every time you set up a system. They're real easy. And, we don't want to leave money laying on the table. So you really need to do these every single time. It's just plain dumb not to. There you go. All right, so the first one is coax cables. This is what a coax cable looks like. If you want to deep dive into coax cables, we have a whole 45-minute presentation about coax cables on our blog site, on our YouTube video channel, if you really want to dive in deep about coax cables. But what you need to know is that the standard coax cable we've been using forever is only 94% shielded, right? And so think if you were doing a plumbing job, right? You're bringing a new water line to your house. You don't want pipes that leak 6% of the water. You want all the water to get to the other end, and you don't want the mess from the leaking, right? So there are newer cables that are 100% shielded, and basically they have 2 shields. They have a woven braid type shield, and then they have either an aluminum foil or a treated. There's certain kind of plastics that they can treat with stuff that make them shields. And this is a 100% shielded cable. And what that means is the signal you put in at one end is going to get all the way to the other. In other words, it's not going to leak out. There's some loss with distance, but that's just resistance. But otherwise, we don't want any other. We don't want the signal that we're trying so hard to keep powerful. We don't want to lose it going down the wire because it leaks out like water. And likewise, we don't want those signals, all that list of stuff on the outside, that's all pressing on your wire it wants in. And we don't want to let it in. So we want to use 100% shielded coax. This is just not a good place to try to save $10 when you're putting together a system, because inevitably this is raising your noise floor, which is shrinking that dynamic range, and inevitably somebody's going to turn or twist or put their hand over the antenna or something else. And when your margin has shrunk, you're going to have a dropout. So we want to use these kind of cables. So for coax, that's 50 ohm cable. We want to use low loss coax, so we don't need line amplifiers, because line amplifiers, while they boost the signal, they bring in a bunch of other problems. So rather than losing the power and then bringing it back up, let's just don't lose it in the first place, or don't lose much of it. 50 ohm coax, I get questions all the time. Can I use 75? And the answer is yeah, but it's just wrong. We can talk about it. There's big long things. Just don't. I mean, 75 ohm coax is for video. It probably has BNC connectors on it that aren't right. I'll catch that in a minute. They snap in and they fit. They're not quite the same size. So anyway, we got to use 50 ohm low loss coax. We got to use 100% shielded coax. We got to kind of baby that coax, right? You don't staple it to a wall. You don't put hard bends, 90-degree bends in it, because you'll get echoes in the wire because you do that. So basically the rule of thumb with coax, when you bend a radius in coax, that radius, most of the paperwork will tell you it needs to be 5 times the size of the diameter of the coax. I generally consider 10 a better number, right? So if you have 1/4 inch coax, that's times 10, that's a 2.5 inch radius. You want to make sure you keep, you don't fold it. And if this system is portable and you're rolling it up every night, that coax eventually is going to get stepped on. It's going to get bent. It's going to get caught in a trunk lid and all that. So if you're a portable system, if you're a portable church, or you're a band that travels around, or whatever, you're a lecturer, and you go from venue to venue to venue, you should think of that coax as expendable. You will need to replace it someday. It's very hard. It takes a very specialized tool to measure it, but it's degrading a little bit every time you use it. So it's kind of like tires on your car. I mean, literally every time you go around the block, you have worn off a tiny bit of tread. And the same thing happens with your coax. When your coax becomes bald, so to speak, it's kind of up to you, but it's losing it's losing its integrity every time you roll it up. So at some point, it depends how many shows you do, and it depends how important your shows are, and it depends how tall your dynamic range is. But that cable is getting worse and worse every time you use it. So you want to remember that. So these are the cables you should use. You can write these down. If your run is less than 100 feet, you can use RG8X or a cable called LMR 195. That's the small diameter cable, the size that probably most everybody uses. I put an asterisk on RG8X because I didn't know until not too long ago that not all RG8X apparently is double shielded. The stuff that comes from one major microphone manufacturer, wireless microphone manufacturer, who we won't name, but their cable is not 100% shielded, but it's labeled RG8X. So it's low loss, but it's not 100% shielded. So you want to avoid that one. LMR 195 is from a company called Times Microwave. It's essentially the same cable. Okay. If you have to run your coax more than 100 feet, up to about 200 feet, you can use Belden 9913 FA, or the Times Microwave number is LMR 400. Those are almost identical cables. Now, the diameter is twice as big. That's why you can run it. So the loss it's got half as much loss, which means a 200-foot piece of 9913 has the same amount of loss as a 100-foot piece of RG8X, right? It's just so you can go double the distance. Much beyond 200 feet, if you got 210 feet or maybe 220, I mean, this isn't rigid, but as a general rule, you don't want to run any length of coax more than 200 feet. It's just getting too long. At that point, you need to start considering RF over fiber, and a device like our optics unit, which allows you plug your antenna into a little box, you run fiber between it, you take your antenna out the other end, and you literally can run the fiber for something like 3 kilometers. I mean, it's a long way. So you can do that. Think about that if you've got an installation, if your wireless mics are on the 6th floor and for some reason your equipment's on the 1st floor and you got to try to snake that wire through 6 stories of it's a nightmare to actually pull that wire. So the installation is a whole lot easier. The expense is a little higher, and when you look at the total of that, it maybe comes out the same. The other thing I would say is if you have to pull your coax through a plenum, if the air conditioning is not ducted, but it actually goes through the space above your drop ceiling, you have to use plenum rated stuff, right? So all the fire codes make sure that you have a cable that if it catches on fire, it doesn't smoke, essentially is what that means. So if you have that kind of a situation, pardon me, you may need to use plenum rated wire. So make sure if that's what you're doing, that's what you're using plenum rated wire. And it probably adds another 30 or 40% to the price of the cable, but that's what you got to have to be code. So that's what you want to use. But here's the one I want to point out, because there's so much RG58 out in the world. That's the small coax wire that you've been using for the last 30 or 40 years. Or it probably goes back to the 30s. I don't know. It's been around an awfully long time. If you've got spools of this out in your warehouse, time to shove it off on eBay or something. Just don't use this cable anymore. Don't even use it for short lengths of jumpers. It causes problems because signals can jump into it and out of it, and it's just a bad place to try to save $10. It's just getting harder and harder to do wireless, which we're going to see in a second. So don't use this one anymore, and do make sure that you're using the proper BNC connectors. Most people would look at these and not see the difference. If you just look quickly, they look identical. But 50 ohm wireless microphone, 50 ohm coax, always has that dielectric, that insulator around it, where 75 ohm, the stuff you use for video and TV, doesn't. And likewise, the pin size on 75 ohm, while they look identical, it's actually just a hair smaller. It fits and it sort of works, but it doesn't make a tight, joint. So you're going to get some noise when it moves and all that. So just make sure you've got 50 ohm coax and 50 ohm BNC connectors. It's very easy to make a mistake. So make sure you've always got that dielectric around both sides of the connector. Okay, so we'll talk about co-channel interference. This is intermodulation, and this is caused basically when you have two radio signals and you pass them through electronics, okay? Because the electronics are not perfect, they generate harmonics, and you can see the harmonics rise and fall with distance. So depending on how close together your mics are, depending how powerful your mics are, depending how many mics you have on. So this is a constantly moving dance as in this case, we got two microphones really close together. Well, why would you ever do that? Well, if you've got a play and you've got, Romeo and Juliet hugging, singing the love duet at the end or something, when they get close together, they're generating a lot of harmonics. And some of those harmonics might knock other of your radios off the air that were otherwise working. And when Romeo and Juliet separate and they walk to other sides of the stage, I guess you should stay on the screen, they're getting farther apart, but they're getting closer to somebody else, right? So when you got 6 or 8 or 10 or 24 microphones, you've got this dance going on, and these levels are constantly going up and constantly going down, and you need to watch them. So what happens simply is it's very easy to understand. When you put two radios together, you get a sum and a difference. So as you could see on that video there, you actually can measure that. You've got another radio station. Actually, you get a whole bunch of them, but the strongest one are third order harmonics. Thirds, then fifths, are a little lower, sevenths, a little lower, ninths, and they go out, to infinity, but it doesn't matter there. Pretty much thirds are your problem, maybe fifth harmonic sometime. Okay, so when you put two radios together, you get two third harmonics. So when you measure two, On a screen, you're going to see four spikes. You now have 4 radio stations on the air. Okay. When you add one more mic, you're not adding 1 to 2, you're adding 1 to 4. This is going to grow really fast. And it grows factorially. So by the time you have 8 radios, and that could be 4 mics and 4 ears, doesn't matter what kind of radios. When you've got 4 radios, you actually have, we can calculate 42,000 actual frequencies that will, the exact frequencies that will become alive depending exactly on where you're standing on the stage. So they're not all on at the same time. Well, they're extremely, extremely low to the point where you could say they're not on, but they're part of that noise at the bottom, right? So the more of this we can eliminate, the lower that noise floor gets. So the first and easy thing you want to do, if you have no other way to deal with this, you want to use the preset frequencies that came with your wireless microphone, right? So, you bought a block and it's got, the A presets, the B presets. It may seem that, I'll put them all 1 megahertz apart or 10 megahertz apart or whatever and spread them very far apart. Yeah, spreading them apart is good, but the exact numbers that they are is what creates the problem. So, they bunch up funny when you do that. So it's not quite intuitive. So the manufacturers have kind of all worked out what works the best for theirs. Now, of course, that doesn't hold when you've got 2 blocks, right? Because their presets only hold if you stay in that 1 block, or if you have 2 different brands working together, right? Now their presets don't make as much sense or any sense depending on how you look at it. Or if you're using in-ear monitors in 1 block and wireless microphones in another block, those presets don't make as much sense. They may make no sense, but they're certainly not as valid. So now you've got another problem you need to deal with. And frankly, the way to solve this problem, the way to do it right, the way we will all have to do this eventually, is you need to have frequency coordination software. Now, fortunately, our friends at Audio-Technica, Sennheiser, and Shure, I left out Electrosonics, they do as well, have free programs. And the new radios will network together, plug into your computer, and your computer will know what you've got, and it'll use the radio and try to measure the frequency, and it will calculate all the best channels. Most of these systems, it'll automatically set those channels for you. So this is freeware. If you tend to use one brand of microphone or another, go to their websites, download the programs. There's bunches and bunches of YouTube videos how to set this up. There's a little learning curve to it. You can use it for a little help or a lot of help. If you're going to try to run 198 microphones and do, the Democratic National Convention or something, you're going to need to be really good at this. If you're trying to put 8 wireless microphones in your church, you don't have to, you don't have quite the same level to hit. So go to their websites, download this software. Now, if you have older radios, you'll need some way to scan that in. Unfortunately, we had to discontinue our really nice little handheld scanner. It's one of those supply chain things that it crushed it. So that's unfortunately gone. You can get scanners, you can rent scanners, or you can buy one new radio and scan with that. Maybe you need one more channel. It might be cheaper to buy the radio than to buy the scanner. Anyway, you need to look at this software and see how this works for you, because this is, if you just use the built-in, automatically find my channels. Well, that used to work a whole lot better than it does now. So I'm going to say, picking numbers out of the air, maybe that'll get you 40% of the way there. We're using this software, it'll get you 98% of the way there. I mean, even if you use the software badly, it'll get you to 92% of the way there. So you want to make friends with one of these software programs and learn how to use it. This is really going to really going to help your setup. I think that more people have problems. All their gear is technically set up right, and they have bad channel selection, or less than optimum channel selection, maybe a better way to put it. And this program will give you your optimum channel selection. That's really important. So the last thing I want to talk about is out-of-band interference. And I have a very new appreciation of this. I mean, I've been talking about it, I understand it, but I just didn't understand how bad it's become, how quickly. It's 5 or 10 times worse than I thought it was. Like I said, we went to Infocom and we set up some measurements, and this is what we got. So I'm sweeping all the way from 400 to 700. So where the wireless mic operates basically is between 470 and 608, above the green part of this. But the problem is that video on the bottom end and T-Mobile on the top end, those are radio transmitters, and they are making intermodulation with your radios, which are the peaks and the above the green, right? So if we put the bandpass filters in, what we're trying to do is get rid of all that solid green at the bottom. That's the noise. And if we put the bandpass filters in, look what they do. I mean, it's incredible the amount of noise. So do you want to try to work in that, or do you want to try to work in this? That's huge. I was shocked how big that difference was. Frankly, I didn't do it. If you've seen my other old video that I did with the spotlight and the bandpass filters, it's doing the same thing, but there isn't nearly as much interference. So, you know, obviously this was at Infocom. We had, everybody's got video displays and big video walls, and just the enormous amount of 5G cell phones on T-Mobile. And there'll be more next week, and there'll be more the week after that. So this problem is getting worse, right? Adam just posted a blog we did with one church where they put this big, beautiful video wall behind their little stage. You know, it's gorgeous. And then it just wiped out their wireless microphones. So you can go read that on our blog and see the things that we added to that. But basically, you know, just doing it right, you know, using the right antennas, the right distros and the bandpass filters, and you're going to end up with a clean, I mean, it's easy. You can see the noise floor everywhere where it's black at the bottom means it's below minus 100, right? So if you use our performance calculator, that's going to ensure that you get a microphone, one of these spikes is at least up to the minus 65 level. So that's, you know, that's 60 dB of, you know, of dynamic range, which is what you want, because inevitably somebody's going to put their belt pack in their pocket, or they're going to put their hand down over the antenna and cut that in half, right? Our calculator can't consider that, you know, the guy holding the microphone is going to just totally screw it up, but that's going to happen. I mean, I watch it happen all the time. So these bandpass filters are quite simple. They're passive devices. You just plug it between the antenna and the input to your distro. So we make 4 different flavors, and this slightly confuses people until you think about it. These numbers don't have to match your wireless microphone range. What you're saying by using one of these filters is that you agree to tune those microphones somewhere between the bottom number and the top number of each one of these. Excuse me. So that's all you have to do. Now, if we look at the top one, upper left, 470 to 530. What if your wireless microphone tunes from, let's say, 490 to 550? Well, you can use that one. Obviously, you can't tune all the way down to 470 because your mic doesn't do it. And you'll be no longer able to tune between 530 and 550. So in other words, you're saying, I'm willing to give up that little bit. You still got a whole bunch to tune to. So if you've got 6 or 8 or 12 microphones, not a problem. If you've got 200 microphones, well, that's a different story. But for most people, that's not a problem. So you can look at any of these. You just kind of pick the one that is most what you're going to use. And as long as your microphone's tuned between the top number and the bottom number, you're going to get that result, and you're going to be able to tune, and you'll have so much less competition from all that noise that you will have eliminated. You will have wiped out T-Mobile, taken that out, and you'll greatly diminish anything from video walls, from LED, just plain LED lighting, right? The power supplies, switch mode supplies, they make square waves, which are radio transmitters, blah, blah, blah. So we're going to knock most of that out. And you can see, I mean, that was in the middle of the Las Vegas Convention Center. I guess I got to play the whole video to get there. So can't do that. Anyway, I mean, that was horrible. And that's probably worse than a lot of people have. But that's pretty common for a metro area. If you're way out in the sticks, it's probably not going to be that bad today. But, sooner or later, 2 years from now, everybody's going to have a 5G phone, right? They shut off 3G. They'll shut off 4G someday, and everybody will have to have a 5G phone. So it's coming. It's just a matter of how long do you want your system to last. So these are the things that just do every time. Use 100% shielded coax. Please learn how to use a frequency coordination software. You may not have to do it today, but time's coming pretty soon where you will have to do it. It's going to make everything better in the meanwhile. And the bandpass filters, I just don't see any way around this. I don't see anybody's system working 2 years from now without these in it. And depending on where you are, they may not work this week without these in it. So these are simple things to do. Don't overlook them. You can be Mr. Happy. I just love this graphic, so that's why I threw it up there. Sorry, couldn't help myself. Anyway, let's just do these three things. I mean, you're just closing your eyes and throwing it over your shoulder and hope you hit the target without these. These will just make it so you focus in. So let's use these. Okay. So that's basically what I had to say about interference. Obviously, we can get down to NASA levels, but you just don't ever need to get that far. It's so hard to work when you're that close. Let's take all the big, easy things and not throw them away. Okay, questions?
All right, we got a few here. Hopefully it's manageable for the team. So where do you insert the bandpass filters? At the antenna or receiver?
Well, it doesn't matter. Theoretically, there's some slight advantage to having it closer to the receiver than closer to the antenna. But, if these bandpass filters going to make 20, 30, 50% improvement, the extra 0.1% isn't really going to matter. So for myself personally, I would make that choice based on mechanical considerations. What's less likely to stick out and get, hit by somebody, right? I want to make the system more resilient mechanically. So I would put it at either end. It's technically better closer to the receiver. You could put it in the middle of the line, but why would you? It'd be hard to hide. So it doesn't really matter.
Okay, great. So this is an interesting one. Antennas pointed at an LED wall. Will the bandpass filters help?
Yes. You just have a stronger signal. The bandpass filters, will bring it down a certain number of dB depending on the exact frequencies. But if you're starting with something that's 100 and it brings it down 80, you've still got 20. By not pointing your antenna at the wall, you may not start with 100, you may have 60, and it brings it all the way down to nothing. So when you can, if you can, you don't want to point your antenna at interferers. You're just bringing more of that into the system. So, for some people, it's a better way to do it. Some people's systems, you have to do it because you've created so much interference. So,
excellent. So, are the RF venue bandpass filters only useful for receiving antennas?
Yes. Yeah, you use them on receivers. So if you wanted to use them with your IEMs, you'd have to buy one for each receiver, you'd have to figure out a way to put the antenna on the top. It'd be a mechanical nightmare. So for all practical purposes, yes, you use them with wireless microphones. You do not use them with in-ear monitors.
All right, great. Here's a good one that comes up often. Will the bandpass filter pass bias voltage for active antennas?
No, it doesn't. So if that's the case, well, first of all, we don't recommend using active antennas one time out of 1,000, one time out of 10,000. Active antennas have a whole bunch of other problems. They give you a stronger signal, but they give you more noise. So in that first picture, they raised the whole thing, but you didn't change the dynamic range. That's the one we want to change. The absolute voltage number isn't very critical until you're extremely high or extremely low, which is mostly likely not to happen. It could, but so we're not worried about that. So, but the answer to your question is, if you want to do that, then what you have to do is use a thing called a bias T, which is another little block that you put power into it. So it's just a way to get power on the other side of the bandpass filter.
Excellent. There's a little bit of a follow-up question here about the antenna pointed at the LED wall. What if you can't avoid pointing that at the LED?
Well, then you can't. I mean, again, if what's a good example? If you have you can almost always relate everything that you want to know about antennas back to microphones. I think most people understand microphones a whole lot better than they understand antennas. So consider, you have a microphone and you've got a singer in front of it, and you've got a gas-powered lawnmower behind your singer. You're pointing the microphone at the singer. Yeah, you're going to get the singer, but you're going to get a hell of a lot of the lawnmower, right? You need to come some other way so you're not pointed at the lawnmower. Now, do you have to do that? No, but then you have to live with the incredibly amount of lawnmower noise. So the point at which it takes you off the air, and there's obviously a point where that happens. If you've gone that far, then you're screwed. You can't do that. But like I said, using the filter is going to pull down the lawnmower a whole bunch. How much depends on how much lawnmower you've got to start with. So that's, sometimes these things are unavoidable. There's no other way to do it, but a less than good way. And then you have to deal with that. So, maybe you have to go buy $5,000 wireless microphones. They'll be less susceptible to that. Maybe you can't use $600 ones. That's the kind of choices you end up with sometimes. But yeah, if you can't reorient your antenna, then you're stuck with what it's going to do, and then you just have to work around that. But in any case, the bandpass filter is going to help a lot. It's going to help a lot.
Excellent. Here's an interesting question for you, Don. With RF over fiber, would you put the bandpass filter prior to the EO conversion or still put it at the receiver?
Again, it doesn't really matter. There's a slight advantage to having it on the receiver side, but it really isn't going to matter very much. I mean, fractional, there's other things that you'll have to worry about more than that. So it really doesn't matter.
All right. So I've got one question here. I'll sum it up. How far away should antennas be from LED light fixtures?
100 miles. So, it's inverse square law. Every time you double the distance, you'll cut the influence from the interferer times 4, right? So the farther you can get, the better. There's not like a number where it stops. You can calculate all that out, and you can have numbers. I could tell you what it's going to be, but in any event, the farther away you can get, the better. So it depends. See, we don't know how strong your interferer is. That's the first thing. It's different on every brand, and it's the power supplies in these things. So switch mode power supplies, which is pretty much what everything has these days. They, instead of, we used to work with 60 cycle AC and we rectified it and we made power. Now we take that 60 cycle and we bump it way up to, 50,000, 500,000, the frequency. We make the frequency really high. And that way there's very little space in between it. So we can use really tiny transformers. The power is much more efficient, but we do it with square waves, and square waves are harmonically rich. And those harmonics, grow and grow and grow and grow, and they become the frequencies that your radios are. So it's the power supplies. I mean, if you have video walls that have external power supplies, like most of the older ones do, you can shield those power supplies, right? You can cover them with metal. You can cover them with, with tinfoil. Better to put them in aluminum boxes or something. But, if you have that kind, but most of the new ones, are a whole bunch of little tiny, LCD monitors all snapped together, and each one's got its own supply internally. You don't have a bunch of cabling, and the cabling from the power supplies is a problem too. So you could try to shield that.
Excellent. I think that sums it up. Try not to create the problem. I think we have time for one last question here, and then we should be good to go here. We really appreciate everyone's time and questions. It's been very interesting. And Dawn as well. Thank you so much. What's a good strategy in keeping your RF channels from clipping while maintaining a lower noise floor?
Well, you're okay. So they don't have to actually clip because of what we call third order intercept. But anyway, I mean, they crap out before they clip. But so when you're setting up a system, okay, this will shock people. I'll get letters, but this is what I would recommend. Personally, me. When you're setting up your system, right, so we got everything set up. We got the antenna, it works its way back to your receiver. You turn on your transmitter and you go look at your receiver and you get some LEDs that tell you how strong the signal is. What you're really looking for is to be more around 80% than being at 100%. Because when you get to 100%, if now that person takes that microphone and gets it very close to your antenna, now you're going to have a much stronger signal than you planned for, right? So by looking at about the 80%, 4 out of 5 LEDs, something like that. And it can go up. Hitting 100 is not a problem. Going over that's the problem. So you want to minimize that. There's actually a thing, and I'm going to do a blog post about it. So most of the time, your antenna is actually too strong for what you are doing. And the pros that do big stadium shows, the guys that do the Olympics and the biggest things there are, they all measure the signal coming out of their antennas, and they pad their antennas. So you get little pads, they're just little barrels with a BNC on both sides that are just loss pads. They're just resistors, and they drop the signal level. I know that seems like, wait a minute, I want all this strong signal. Yes, you do, but you don't want any more than you need. So they drop that. If you go to ProSound Web, Ike Zimbel, who's the specialist guy in Canada, put an article there, and he's talking about, even with 150 feet of coax, I still pad the antenna down because it just has more signal than I need, and more than you need becomes the problem. So that's really how you do it. For most people, you shouldn't have to do it. It's an advantage. It's a small advantage. Like I said, if you're doing Elton John at the Enorma Dome, you want every last quarter of a dB you can get. You don't actually need it, hopefully, but if you do, it's there. So they pad their antennas down. I mean, you just don't want to, you don't ever want to get closer than 10 feet to an antenna. Depends how powerful the antenna is, too. Depends how powerful your transmitter is. I don't know either of those two things, so I can't give you a definite number. But you don't want your antenna here and your microphone here. Bad things will happen. You'll screw up the front end of your radio, and then eventually it'll drop out or distort, or it won't be good. Let's leave it there. So the way you actually do it is pads. So theoretically, basically, it's very simple. If you put your transmitter on a stand, turn everything on, go look at your LED meters or whatever indication, your RSSI, it's called received signal strength indicator. And you don't want that to be 100% all the time. You want it to be down 80. It's going to bump up. It's going to move, right? Okay. So if you're at 100%, get a 3 dB pad out, put it in the line. Now go look at it. You're still at 100%. Put a 6 dB pad, and you'll find where you get it back down to 80. That's probably beyond what most people are willing to do. I just keep a bunch of those pads in my toolbox. They're cheap. They're 50 ohm loss pad, BNC loss pads. You can buy them on Amazon. They're 10 or 12 bucks a piece. So if you've got a whole lot of signal strength, it actually makes the radios work better. So radios actually work better. The sweet spot is lower in power than higher in power in whatever its range is. It increases the sensitivity of the receiver. So you'll actually make the radio better by feeding it with a lower signal. I mean, you could put 500 extra feet of coax in it, but you don't want to do it that way. I mean, there's loss in length with your coax, but just a little 3 dB, 6 dB, 9 dB pad is the way you actually treat that.
Awesome. Thanks, Don. You answered the last question here without me even asking it to you. So I think we can mark this one very successful.
Cool.
And so thank you, everyone, for joining us and hanging in there with us and asking all your awesome questions. You feel free to email me directly if you have any follow-up questions, adam@rfnu.com, or if you want the recording of this session, I'm happy to provide it. I will be posting it, however, on that page that I shared earlier. That's our main webinar page, and they're all going to go up there. So be sure to bookmark that so it's easy, but I'm happy to send it to you directly if you just contact me. So as soon as it's ready, I'll provide that. So thanks again, everyone, and I hope you have a great rest of the week. Thank you, Don, as always. I always learn something during these, so I appreciate it so much. I'm sure everyone else does as well.
All right. Thanks for spending the time with us, guys. Appreciate it.